Good morning, everybody. This is Engineer Suraj Singh speaking from Bharat on this day of March 8, 2021. Speaking to you again, good morning, and hope you are fine, healthy, COVID 19 free. I am sorry again, problem in this. Good morning again. It happens. It's giving different. First it's giving 1 minute, now it's giving point 2 3 minutes. I don't understand this. Well, no problem. Let's go through. It's talk of quality in life and in particular in civil construction, civil engineering field, which includes designs, which includes construction, methods, contracts, EPC, Annex, which includes for quality management, quality organization, and then communication, coordination, quantity, quality, etc. etc. I want to bring to you as much as possible during these talks because these talks are very significant from experience point of view and to learn what others did. It is very reliable way to learn from others if they have real experience, not book experience only. But it depends upon recipient what percentage of interest that recipient takes, because it is very serious talk. All such talks have been very serious, and when seriousness comes into play, into scope, we can simply say that it's very boring. Just like people say work is always boring, but I don't accept that work is always boring. Work can never be boring. If it's real work, if it's used, it's produced, it's used for people's benefit, people's welfare, or it's used for people's lifestyle, you can say people's quality. If you want to improve quality of people, and for that we use mind, I use, you use, everybody, every professional uses mind, every every technician involved uses mind. Of course it can never be boring, because use of mind can never be boring. Even though entertainment can be boring sometimes, you know, dancing can be boring sometimes because it's repetitive, it's on its own. But when you say mind use is extremely significant in life. Those who use mind, I think they are best people who can never bore themselves, they can never bore others as well, because it is as such. I am showing to you this quality title. It's not only for me, but also for everybody all over the world, and in particular to our country, in our country, India, Bharat. I can say quality must be considered very seriously. We have ignored it in past, and we should not ignore it now. Quality means reality of life. Why to pass quality? Why to overrule quality? Why to ignore quality? Why to condone quality? Question arises. Why not to think of quality first and then work? After all, why we run in a direction which is not guided? If we ignore quality, means we ignore something and we get only few percentage of results worth, your money, though it should not go, it should not have gone wasted, but it goes wasted because we are not serious about quality. Why we are not serious, you know very well. Answer is that people are not means they are just interested in money. maybe small guy or big guy, small worker or big worker. I don't blame workers actually, they work. Whatever you give them, they work. I blame whole system. System means after all who is responsible for system? Again I would stress that each and every body of us is responsible for system. After all system we establish, we generate system, we agree on system, but we do not follow that system, or we follow for purpose of formality, and nobody should say you did not follow it. Even these quality audit which are conducted, internal audit and external audit. Name is very beautiful, internal audit and external audit. But question is audit. After all, what do we audit? We audit nothing, to be very frank. If you go for 1 day, 2 day, 3 days in certain organization and audit, you cannot find out reality, because you will find generally documentation is perfect, if not perfect, near perfect. You may write 2, 3, 4, 5 observations and come back. What does it mean? Means it is your own, whoever system, whatever system you are managing, organizing, it's your input. Means I don't know reason why do we run away from quality when it doesn't affect on time, it doesn't affect on, it doesn't affect on anything. But if you ignore it, it affects everything. It affects time, because repair time is required. If you do not care for quality, means your product shall not work, shall not perform to its requirement. Time you need for repair, or you can say reconstruction or rework. If you are caught, time you need, and also money you need, cost you need. Then why don't we become very serious about quality? This I cannot understand really. I don't understand any reason out of this. If you think you will save money, I think you are living in fool's paradise. Nobody can save money if you ignore quality. Yes, you will get bad name certainly, if not today, next time. You will not get anything and your reputation would fall one day. Your big signboards, advertisement boards, your very good offices, your very good filing system, but contents are absolutely nonsense. I don't know, I have seen very big companies also doing same thing. Very strong, oh my product is best one in world. It's unequal, and when see its performance, I think you have no comments on that. You buy something, there's no guarantee. Yes, there is commercial guarantee, but why commercial guarantee if product is very good? Product should prove it's good one, its performance should prove, but it's not proving, it does not prove. And simply we say if you ask some person who's auditor of quality, or even if you ask ISO 9000, organization system, they will say we are not responsible for product quality, we are responsible for system quality. I don't understand this. Why this difference? When system is quality and you certify someone, your agency certifies someone, I'm not saying ISO certifies, ISO doesn't certify. If your authorized agency certifies compliance with ISO system, ISO 9000, why should there be no quality? This is equation which I can't understand. That type of equation it is. It's very simple to withdraw yourself from responsibility. But when you say, oh, we claim the standardization organization, then your standards must work. And of course, you say it's cooperation of people. Yes, it's cooperation of people. Why shall not people cooperate? Question arises. People like to cooperate. After all, if I spend money for good material, for quality material. Why should I spend money for scratch, for scrap, for RAV, for garbage? Why should I spend money for that? My money is hard-earned money So I expect material to be worth what I am paying. It comes back, but it does not. So there is no criticism on anything, but criticism in blanket in general. That quality, I think, does not exist in every field, on every product. Whatever country you buy product from, you cannot say product is reliable, safe, serviceable, is durable. It shall work according to its demand, its claim. It shall work a claim. Claim is done, but it doesn't. For example, if a student in engineering doesn't study very well in examination, that pass also, that will pass, of course, with low percentage of marks. But question is, low percentage of mark gives you quality? I think no, because that person has much deficiency. We can understand that time this person is not very high quality person, but a person who has succeeded distinction, or you can say high profile mark sheet, we expect that person to know at least theory, if not practical. And if that person also by chance got same questions studied, you can't expect that person to be good even in all theory subjects. So quality is much different. Academics is other one, while you see virtual world or practical world has different dimensions. Here quality means you should get what you claim, what products claim, what producer claims. Product should witness that. Product should be of that standard. I think very rare cases prove it. Very rare cases. It's a surprising. I still remember those days when it was very 40, 30 years back, 20 years back. Quality was existing. It existed. Even if today you buy a computer, say I have a computer of 2008 purchase, which may be some years back manufacture. That is system. And today's system, when I go for repair to service center, I mean to some technician, not company service center, because company's service center never access product more than 5 years old. So when I go for that service, that technician always says this is old, this is very durable, this old is gold, and if you today you take means it's no comparison. Means it's not too late. 2008 I purchased, and even today it's working, and it's very heavy, and it says old has weight. And now this time today shall become old sometime else to come. Everything is small and beautiful does not mean it is quality. Means quality must be inculcated, only then we can say performance is qualitative. Though quality word is not that significant, because now it is significant in absence of real quality, because in past people were hardworking, they were sincere, honest. This quality property, this quality parameter from individuals have gone. Hard working has been turned to smart working, and smart working cannot replace hard working. Determination that existed before is no more existing now. Sincerity, what is sincerity? I don't understand meaning of sincerity now. What is sincerity? And of course people work from home. That is another way of working, virtual world. But question is not that. Question is, after all, our attempts, our efforts, where do they take us to? That's first point. Where do they take us to? If these efforts we make, these take us to worthless quality, I think we are wasting time. Work wherever you work, but if not to mark, standard mark. Your performance is not a standard mark, but you want to sell yourself, and there are people to purchase you. Well, I think the quality does not play any role. And quality does not play any role means you cannot find quality product. There are products, beautiful packing, yes, packing is really beautiful these days. You will find packing as if some gold has come to you. But if you open that, it doesn't have quality product. By chance you get some very good company, organization, or patented product, you can say 1 to 2%, 3%, cases 5% cases maximum, you may find something reliable. But if you take on overall basis, nothing as such, nothing as such you can say is quality product. We can't find anything that refers to quality. Quality has become like wood. You cry in wilderness, you will not find anything. You keep shouting, keep demanding, you won't get. Even if you complain, there is no meaning because there is no one to listen. Quality working, quality performance. Even these services, these service providers of mobile, they don't give quality. You consider, say I'm talking to you, maybe in a couple of minutes the signals break and they don't take any responsibility. They say this is technology. Well, if it is technology and you accept that signals can break all time, this means you don't have any control on them. Who has got control? My question is that if I'm talking to you now through this video, and it happens often, I talk and sometimes signals break and video is off here. If this Facebook would say, oh, your video has ended. Yes, it happens, so I do again. I do continue again by another video. This means there is no control. Why should it break? Either people are sleeping or even if it's automated, there is some error. Why should it break? Signals are yours. Okay, bad weather is other part, but when there is no bad weather, it should not. And if you complain, they'll say, oh, we'll take care of this. We'll search out, we will investigate. You don't know why it happened. That's what I say. Technologies do not claim quality. I think it's not technology that's defective. It's people who are involved with that, maintenance of that system, operation of that system, you can say. Operation is defective, there's no concentration. And this computer has even made people to sleep. It's sometimes, there's so much time during its operations that you are idle, you are not busy, it happens. And that's where we lose. It's two different ways. You see, you are driving an ordinary car and one time you are driving automatic gear car. So when you drive ordinary car, you have to use accelerator, you have to use clutch and brake, all these three. But when you will drive, in automatic gear, then clutch system goes off. Only you have to use one leg instead of both legs. Apply brake or apply accelerator. So you feel drowsy when you are driving at high speed on open road. There is no rush, nothing. And you have been driving say for 20 minutes, 30 minutes, 40 minutes, 1 hour. Of course, you feel tunneling. You feel the car is not moving. Though it's moving at speed of 120 km per hour, sometimes you feel, oh, this is moving 40 km. Because you have been habitual to that. Your leg is just stationary. You are just sitting, thinking something else, and maybe you feel drowsy. This happens. It's very dangerous, but this happens. So that's why I'm saying there is a difference in approach. One is manual system approach and one is automatic system approach. As much as automatism you reach, you will find yourself drowsy, lazy, because your involvement in that act has gone or reduces. It has reduced certain levels where you say, I'm not fully, you have to sit there indeed. Indeed, nevertheless, you can't do anything else. So I mean to say, we have to understand these points are really, quality is therefore very much good parameter as well. Good, not parameter, you should say. It's a system. A system which must be inbuilt with quantity. Otherwise, your quantity is rag. I can say rags. It's rubbish. I can say it's throwable. People say such products don't regard this country's product don't together. So question is not guarantee or no guarantee. I don't believe in guarantee or warranty. I believe in quality. If your product is quality, I am happy with that. It's not personal. Even if you use your kitchen for cooking, you cook, you prepare tea, or you prepare something else. It's your quality your own quality means you decide how much you have to add, and you every day you eat, you make it, you cook it, and eat it or drink it. Your quality, you understand. Quality has no definition, to be very frank. It has no vistas. It's your own vistas. What do you need? Quality is only means what actually do you need. You have to achieve it. It doesn't mean anything else. I accept one part of quality, you accept another part of quality. For me, this is quality, for you, that point is quality. There's this difference can exist. But when we standardize something in interest of public or we in interest of professional interest, we standardize something. See, steel is standardized, concrete is standardized, aggregates are standardized, gold is standardized, aluminum is standardized. There's some relation to which we measure our quality. It doesn't mean that this is measured quantity. This is controlled quantity, defined quantity, confined quality. Means you have to produce this much minimum. It doesn't mean you cannot go beyond that. Because whatever we thought we should achieve this limited standard, that's our specification. Means we specify we have to achieve this level, and that's it. But level is about that. If you go about that, you'll find more requirement. So it's therefore very different. I can say this is very different talk and very different. Here quality is not. No, I'm not talking normal quality. I'm talking innovative quality. Quality and this job of engineers, because they are very highly profiled professionals. High profile, engineer is high profile professional, and means high thinker, highest level of thinker. And if thinker cannot think, if engineer cannot engineer, this means thinker cannot think. Well, you know what I mean. Thinker's job is to think and develop. Think, do, and deliver. This is the job of thinker. This means this is the job of engineer. To think, to do, to deliver, and before deliver, check it. If you don't check it, if you don't find errors, and if you find errors or defects, you do not improve them or rectify or remedy them before delivery, then you are a sleeping person. A sleeping person means you ignore something you should not have done. Ignorance, you can say, is bad manner. Why should I move shortcut? It's my role is, even if I feel bored, I have to do that. Means something which goes beyond my control, I have to move to that level to control it. And if I don't move, means I leave something, I don't work properly. You can say that. Working properly is very important. So that is quality. Quality is not dream, it is defined. Quality is not unexpected, it is necessary. Something unexpected, you may say, oh, I did not expect that. It is, it's like unknown event. It's not unknown event. When I start something, there is some quality definition, in which spectrum, in which domain I have to work. If I go beyond that, that's fine. If I can do for its modification or better product, there's no harm. But if I do nothing and I claim I have done it, then it is sheer lie. You think lying will work? Never. Lying is cheating yourself. You may say, I lied and you accepted. Okay, you lied, you accepted. But what shall happen next time? What happens to your reputation? You may be happy, you feel happy, okay, I've done it. But you've not done anything. You just lied. And that's no formula. Hiding, lying, concealing never can get you quality. Quality requires complete attention. I know metal is used, cost is spent, time is taken. But ignorance, overlooking, condoning, oh, we'll see later on. Sometimes people think, no problem, let's go on and see later on how to do it better. And it's never done. So quality does not come in. Quantity can come in, but quantity without quality is, you can say, rubbish. Scrap, kabara. You may give good polish to that product. You may give good coating to that product. You may give very good packing, transport packing and delivery packing. But packing is no destination there. Your sale is for product. Buyer will not respect you. Okay, one time buyer may not say anything, but that buyer will not buy again same thing. And on top of that, your service is also poor. Sometimes if you cannot give quality product, you should give satisfactory post-sale service, after-sale service. That too also some people can't give. So you have to just buy quality-less product, and that product is not worth. But because you have no option, for in quality. I don't find quality in general in any product, to be very frank. They may say, I may be happy to think I got quality product, but when I use it, I really feel disappointed. It doesn't matter which company it comes from. This can come from highest profile company or from a street vendor. If product doesn't have quality, it doesn't mean anything. That's only emphasis I'm trying to give on quality. In very general, I am not going to confine to this quality specification or that quality specification. That is applicable in all cases. My intention is to talk in very general. What do we understand by quality? If we understand quality, why don't we achieve it in general? And what is problem in achieving that? Can we understand that? Can we analyze that practice? If we are able to analyze that, where is absence of requirements? What is reason behind that? Well, I think we can do better. But that requires your attitude, good attitude. If your attitude is not towards quality, you can never achieve it. If you think what it is my objective, I have to sell this, you can sell it because people trust you. Maybe one time, two time they buy, but they will never buy after that. That's also true. So your market fall. It will fall. No way out. Your reputation will be at stake. So future of your product is dark, and future of all product dark. So it's my reservation, it's my observation, it is my rationale. Quality is a must. And importantly and significantly, in quality at least in materials or products and services. Generally, engineering professionals from all branches of engineering are involved all over the world. These engineers must know meaning of quality. No need to teach them. They are educated academically and maybe having some of the experience also. And there's no way they can't understand what quality means. They understand very well, and maybe they are happy, they intend to use it, but circumstances turn them away from those effective activities. I am saying effective activities because quality achievement itself is effectivity. If I don't have any system, I can't do anything. That's also true. Going further, I would say quality is something we can't say it's not. It is something very important, and it has to be understood in that spirit. It has to be understood in that spirit. There is no way out. Quality requirement, quality checklist, very important point. And I had given to you many it out. Many items we talked, many items we talked, we discussed. And I'll go further on that. But before going further, I will talk something which is very, you can say, which is very important, and it's just an example I like to give you. Not that it's a claim, it's just a kind of reference to understand about quality. Means what actually we desire, what we desire and what we do, that is different point. I'm just trying to find my concrete issues which I did last time, footing concrete board. There's a file which is giving you something which was done in 2008 to 2010. It is done, a house it is, and you can say this is my own house actually. It is in Faridabad. So all dimensions are in millimeter unless notice otherwise. Levels are in meters. Major dimensions are given in feet as necessary. Well, that's something else now. Floor to floor is 3250 mm. Riser is 125 mm. Tread is 250 mm. And height of floor is 10 feet 6 inches or 23250 mm. 8 feet is equal to 5. Well, now this is, you can say, a house. This says basement here. This is profile of basement, like this. And this is about, you can see, center to this one is 10.2, about 11 meter in total. This is 11 meter here, more than 11 meter, and 10.2, and it's here. This is 1.7, more than 11.5 something meters. I'm not talking feet. It's meters here, and this is 10 point something. This width is hall portion, and if you see, I'll just show you first. Then you can say this is basement floor plan, and here you can see columns are placed in solid texture, black texture here. These columns, as a framing of that building. It's framing I'm trying to show you. A, B, C, D grid, and this 1, 2, 3, 4, 5 this way grid, which is a standard way to work. And then you can say it is, if I go down, basement structural general arrangement, then now you can see go to ground floor. You can see here it's rear of this building, rear, and this was already constructed in this. This is proposed one here. This is here. This is hall I was talking of. This is a existing portion here, and this is hall here I'm talking of. The ground floor of this hall, and here is structural arrangement. Then if we go further, saying ground floor at rate of plus 1.25 meter from driveway, so it's higher than from driveway. Architectural ground floor plan showing general arrangement. Then you can say this is another floor next to ground floor, first floor, call it, and it is all, you can say, structural arrangement here, and these are your double height. This portion hall is double height, means double story, you may say, not is floor to floor height is double. And there's balcony here, 1.8 meter and 1 meter this way, and there's same way 1 meter this way here, and this is there. So main balcony, you can say this is main balcony. Also there is inside, there is a balcony here. It goes this way. So you can say, if you go further, you will have architectural first floor plan showing general arrangement and slab cut out. And then here is another floor, that is next floor or second floor, where your this staircase ends, terminates here. This terminates here, and this is study room, and this is a bathroom here, like this, bath area and kitchen, whatever this is. This is study room. Of course, terrace here, terrace combined big terrace with extension of all this, and this is now architecture. I'm just trying to show you architectural second floor plan, general arrangement and terrace. Now this is some drawings. This is above study, this terrace, above study, and here a staircase, this portion, and now you can see its roof, and this is staircase cap. This is room here. Ordinary, if you see in section, you will find that this portion here is this, and like this it is. Level 10.10, 10.1 meter. Now architectural penthouse, general, okay, you can call it penthouse arrangement, stair cover. Now these are something, elevations. Let me just blow it down. You can see these elevations. If you see, it's terrace here, staircase cover. This is your stair, window, door, entry to terrace, and there's a bathroom here, entry, window of that, and these are elevations from that side. All brick, and this is windows here, all windows glazing. It's a different type. It's a basement ventilator, and here is existing one. So this is elevation, front elevation, architectural front elevation showing step windows to transmit sun rays. That was purpose of that. As much all sun rays should transfer here through this opening. through this glazing, so that there is no requirement of using electrical bulbs or tubes in daytime. And let's go to see elevation. Other elevation, if it is on south, it's on south or north, whatever. It's probably on south. You can see same. You see windows here, stepped windows, all these here, so that there's no barricade from sun. Sun should freely enter building. Stepped window for sun rays. Then you can say left elevation showing stepped windows for sun rays, particularly in this new construction here. You can see how big is basement window, ventilator, and these same windows including ventilators. You may say total light should be there in these rooms, which you can say which contributes to green standard of building. So that's that one. Now we go to parapet design. Front parapet, left side parapet, internal balcony railing. So you can say front. What sort of design is this? You may say this is only brick here, and this is railing, parapet railing. It's done in this way. Then you can say other. Next one is other. This is a left side parapet. You can see this sequence of design. Purpose was to use minimum quantity of bricks, and it should add to elevational arrangement. Also internal balcony, which I showed to you in that drawing. Internal balcony is also devised or designed like this. Stepping parapet, it is called stepping parapet. And then you can say stair cover and penthouse roof slab cut out at periphery. And here it is. This is roof which you are which up there. This is profile of roof. This is the front. These teeth have been designed like this. Teeth like that. And this rear is a straight line. And this in front it looks like as if you see from ground you look like something very specific. Of course it's based on structures, you see. Slope and roof and covering stairs, and this is stair cover. And the slope and roof is same. And if you see section here, you will find this is that section. This is your inclined roof, and this is like that. Stair roof cuts periphery. Now we come to structural arrangements. You can see that basement structural general arrangement. This is basement. Water tank below basement between beams. What we did, this is hall, below hall. This is basement. You can see columns, what sizes are these? Depending on span, which is much here, 11.619, say 12. This is 12 meters span, and no column in between. This portion is free of column inside. Only these columns, and this is stair portion. This portion which you see is water tank below. Water tank below about 60. You can see yourself. It is how much? This is 16 point something. Yes, 11. Let's say 11 by 2.7, or you can say exactly 2 point something, say. So 11 into 22 into 60.6, so 20 to 6, about 16,000 liters capacity of this below, basement tank. You may say basement tank, basement foundation tank, because These beams are there already, and this tank is surrounded by these beams. There's no special arrangement for tank except bottom concrete, bottom raft, and slab. And these are access manholes here. We provide actually only two, one here and one here later on. This here, so these are here. You can say how it is. Then we may say that further we go basement structural general arrangement. Go to now. This is beams structural arrangements. Foundation beams framing hull portion. Foundation beams framing hull portion. This is foundation beam here. You can see yourself. These grids A, B, C, D, 1, 2, 3, 4, 5, 6, 5, 5. So this is, what I'm interested in communicating to you is that, let us say this is foundation. This is going like this and coming back, going this way, and all columns are connected together. All columns are connected together in a grid. Means A, B, C, D, 1, 2, 3, 4, 5, 6, all are connected on X axis and Y axis. And if you can see its section, you will find this is a section here. This is you can see this way, and also you can see this way. So it is complete connection, and is called soil retaining wall is here, and water tank retaining wall. I had all retaining walls, external here. This is all external retaining walls. It's all retaining walls here, not in between, around periphery. Then you can say, let's go to see how it works now. It works foundation beam framing plan. Then you go to another sketch, and which is of same but different type. This is you can say foundation plan. Let's say first of all, what is foundation says? What is foundation says is something which is really wonderful to think of. This is your foundation plan. I mean say foundation section. Is it in soil improvement first? Then it is 300 mm here. You see, though it looks as if it is concrete, but it is 300 mm. This portion was clay. We remove this, and after removal we replace with graded fill. Graded fill means aggregates and dust. It's very important part. Means I didn't like clay presence here. I replaced that with graded fill, or you may say structural fill, interlocked structural fill. 40 mm aggregate pulled in, voids of 40 mm aggregate were filled in with 20 mm aggregate, and then they were filled in with 12 mm aggregate and dust in this portion. So this is a kind of soil improvement, having voids, having permeability, having, you can say, if water moves in below footing, that can move here. Clay does not allow any movement because of high degree of porosity in clay, but because it's now graded fill, water can pass comfortably. It won't harm your building foundation. In case there is soil and water movement, small size silt particles or clay particles may move with soil, with water mobility, but won't harm this. You can say won't harm this your foundation, because it's now macadam base. You can say macadam base rather than saying something else. This is water-bound macadam, that a kind of road below your foundation, a kind of road. It's very important understanding if you can do that. And here is a beam, you can see. Of course, there's waterproofing here, which I'm saying I did not tell you. I applied, chemical waterproofing here, polymerized polymer cement, you can say. Polymer cement was included permanently here in this portion, complete polymer cement, and here is this profile, you can say. This profile is RCC. Actually, this 400 is even here. This 400 by 120 here. This is real beam which is resisting bending moment and forces, other loads. This there is steel in this, everything I will show later on. And this is spreader. Load comes here, it spreads here, and also this is damper, means it can be used for including in calculations of horizontal accelerations or seismic forces coming on this beam. And other point is that it's not calculated like we do in footings. It's footing but not isolated or independent footing. It's different. So we have 2 points here. One is soil improvement, means we improve safe bearing capacity of this soil, at least for taking immediate load. And when it's a 300 mm, so this suppose load comes here, it shall certainly go here. So this portion at least is used for enhanced capacity, enhanced safe bearing capacity of soil. And from here columns would come out, means column is nowhere except coming from here. We raise column from here. This is just kind of different type of. Here beam sizes are given, that's different. Now we are seeing what we are seeing is that this is your beams which are talking issue section. Here is all these beams are section. Only difference is this edge beam are all same design now, internal and external, because all these areas inside and outside are free. There is no except there is no problem. One side is all accessible areas. So you go further and see basement -1 point, whatever level it is. This is structural framing, basement structural suspended slab framing plan. It is. Now we go to another plan, and that is, you can say bed sketch 92. A number is different. This doesn't matter. Bedrooms and wet areas, all columns on first floor, size this, all beam size this. That's written here now. This is, you can say, structural arrangements. Again, same structure I kept. Did not change anything. And these are all upstands, here in external, so that down stands are only in between, in middle. Then we can say ground, the structural framing level. This is ground floor structural suspended slab framing. Then we go to the one here. This is structural arrangement in all. You can say here. First structural framing, first floor structural framing level, hall portion. On hall, what I provided is this. If you can see here, stair is this is previous portion here. Now this is connected to this one. Previous is connected to this one. Previous here which was. And this is staircase coming from basement, rising from basement to top. And this is your wide, no slab here at first floor. This is access balcony. To go here, this balcony, and this external projecting balcony. And if you see this slab, so this is balcony. It's like circuit. This is a balcony. Like this, you go, come here, go, come down, go, and come again here, move here like this. It's like ring. Got it? I'll show you now. If you can see this balcony, say it's internal balcony here, This is internal balcony. When you come inside, you go here. Let's say this is external, open. It's not open to sky actually. This is uncovered from sides. So this is balcony, which is not taken in covered area. You can walk here. You can go here, go here, go here, and go here. You can go here, come down, come inside, again come outside here, and you can see this way. It is closed circuit around. Circulation is 360 degrees. You can go this way. This is beauty of this circuit. Now these are all balcony beams, cantilever, and as usual go on first floor structural framing plan. Then this is, you can say, second floor structural framing plan. It's almost same except that there is no hall here. It's complete interlocked slab below hall. This is all hall portion, like this hall portion, and it's, you can say, roof second structural framing level. It is that. Now here is, most difficult part of building is always staircase. People don't realize this and they make mistakes. Staircase, I understand, should be considered when you start design of whatever building. Most difficult part that creates problem is staircase, which people don't realize and they suffer later on. If you can draw and you can say, you can understand stair properly, you can devise floor height. You can't devise floor height without consideration of stair, because your floor height should be such, based on my experience I'm saying, should be such that you should not give decimals risers. Risers should not be in decimal. It should be round figure. It can be 150 mm, 125 mm, 100 mm, 180 mm, 175 mm, whatever you want to keep in comfort. Of course, in residential building, higher value can be accepted, but why? If you have plenty of space, then stairs should be comfortable for every age person, for kid, for old, for young. It should be okay. If young are too smart, they are energetic, rather than rising one step at a time, they can rise two steps. Suppose I keep 125 mm riser. Of course, less than this is no good, except in public areas. If I keep 125, as I did in my case, in 125 mm in my home, this means when you take two steps, you reach 250 mm. So this is that case, what I'm trying to show is that case. You can say here, this is, we start here, let's say there's a beam here, we provide a specific beam for stair. They say that this is one, two numbers are given. You can say it moves 125 mm by whatever size, probably 250, I don't exactly remember now, and it goes this way, then it goes this way, and then again it goes this way. You can say 72 numbers. So it may be 72 here, but actually it was old design. And then there are other steps here at every floor to cover up basement, because at ground there are two levels in this building. One is without basement and one is with basement. So there must be a difference in the construction. Whatever is there, we have to take other steps there. This point here we understand. Step, and you can say it's very important that you have to be careful about staircase, and not only careful, we have to give dimensions of that for purpose of form work. For example, you have to give that. If you say this is here, this point is here, and this is waste slab soffit here, it goes like this. Then you have to see this is another soffit here. Carpenter needs this dimension, what carpenter? He had to put shutter here, right? He has to put shutter here, right? You cannot do without that. That's mandate. You can't give this dimension alone. Okay, I'm giving you this dimension, do it. No, that's not right. He will not say yeah, no, but he will get confused. He will draw here all this and waste time, and you won't get what actually is. So because we have software, we can just give real dimension here for shutters, for formwork, top of formwork. This is real dimension, and from here also you can say this is real dimension here. We have different dimensions as well, means here for example I'm saying 3629, this is other one. Whatever we can give, interest is in giving, you see, which requires formwork. That's important. Top will be managed because it's difficult to find this dimension directly, and also it's difficult to find this dimension directly. And then its height from here, from floor, you can see you have, so that you can fix at this height, this dimension and this dimension. These are required for ease of working, and it's not difficult. It responds because if you want perfect staircase without any hitch, you have to make a drawing of that. This maybe you call it architectural drawing, you may call it a structural drawing. To my health it doesn't make a difference, because both are my professions. Without architecture I cannot do structure, and without structure architecture is meaningless. It doesn't matter what degree I have, but it's a combined, it's overlapping, it's combined profession. When we deal with drawings, we deal with both drawings, architectural, structural and services also. So this point to understand, its best way is to design stair first. I mean, stair design is not in drawing but in calculations. We should know what we are going to do. That's main point here. So this is total stair. You can say this is basement portion. A small portion here, the height of basement is less. And then you can see this here. Height of less, not because of floor height, but because we are going from, there's a difference in floor level of two. One is old and is new. Then it is stair architectural framing, channel arrangement. Then now we go to other. Well, this is nameplate of building, so don't worry about that. Then we go here. If you say this is, this is driveway, right side window, this is in driveway, that side is front, this is right from that, and you can see the same window which we talked of there, same type of design we did it. I mean, of course little different but same. And also here, this is right side, you can see sort of windows here. Let me just break it up little so that you can see little clearly. You can see that. So here you can see that here. It's drawing. It's very important point here, you understand. And you can see the first floor here. You can see profile of parapet. This cantilever beams, you can see that. Without beams I can't construct balcony. It's cantilever after all, and people just pull it without beams. I don't know how strong they are that they can take risk of future. But design is design, requirement is requirement. I don't want to take any risk, so I did all these, beams coming from inside and pulled in, axes drawn in, and you can see this is a cantilever beams, and here slab. So if you provide beams, and this is not seen from this end, there's a torsion beam here, torsional resistance it gives to all these cantilevers, and it's easy in that case. Means this is 1.8 meters, or 6 feet, you can say 6 feet. You can see this. Now, building view can be compared to conventional building. That is, if you see front here, you see these windows are telling something. Windows speak something. This parapet is speaking something. What we call it, beauty of art. And you see, it looks different. If you compare this another building, which was, you can see both are different. Though this is having very dense material here, very heavy type of building. You see here, there is no light. Even there is light here. There's no light here. That's the difference. Then view this from distance. If you see this from distance, you will find that one. See how it looks in this. Because front is little wider, that's also benefit in this. Front is in this, about 3 times than rear. They call it trapezium size, or they call in their religious way shirmukh. It is shirmukh. You can say that. It doesn't, to my health, to my mind as engineer, I don't find any problem in this kind of thought. It doesn't make any problem to me. It is shirmukh or not shirmukh, or what mukh it is. That's point is different. The building is side tracked, and then you can say, I'll come back, no problem. But it's like that. I'll discuss. Meanwhile, you can view this building if you wish. How is this? Means this is something concrete. I leave it here for 2-3 minutes. Just so you can see what actually it is. Just a minute, please. I'll be back. I thought that I should show you this very important one. Very important point, very important one I wanted to share. So I copied it from other computer and put it in here for your reference. It was done in 2008, 2010. This was constructed. Now it's very old, but I just wanted to discuss structure of this. How structural it's to nature. How can you do maximum work and minimum expenditure, minimum expected. It's a problem with me. Standing is a problem. Once I sit for more than 1 hour, it's very difficult to stand up because of my legs problem. And maybe people say, why go all time? Because I have to stretch my legs. I can walk, you see. It's a problem here. Oh. Oh, God. to do. Oh my god. Helpless. So, this you know what I did. Well, you might have seen by now what is that. So I come up, close look or something, it's same thing, it's no difference. Just different views. Now it is internal. You see, this is internal balcony I was referring to, that I showed internally. This is internal balcony elevation and LED illumination. You know, these LEDs are here. This is a fence, ceiling fence, internal balcony. This, you know, people are confused little sometimes. This will put tiling on that. No, there's no tile on this. This just RCC fair face surface. You know, only RCC surface. This is, of course, this portion is not RCC. This is block. RCC is clearly seen. Our structural beams are there. There's RCC. This internal parapet here. And this is beam portion. This is beam portion. And this is, you know, parapet portion where you see stepping. And this is all RCC structure. Complete framing. And this is beauty of this house. This portion, you see, this is brick. This is brick here. And something doesn't. This is all slab, beam, skull column framing. This 11 meters something, that says something this much. And here is, you know, this all brickwork, you know, and this is your slab. Again, I'm sorry, beam. And if you go further, you'll find something consistent with this beam here. This is double door, which was seen in elevation. And this is here, I can say this is brick wall. This, you know, reverse window. And without, there's no need of any lintel because I'm using beam as lintel. So high, this is actually ventilator space, this is window space. So I combine these two and avoid wasting material. Only this block work is done. And here you can see this is staircase inside. The electrical board here, and this is structural. Here you can see. Then you can see this is from, you know, stair from ground to first. Here it is, and this is. Then you can see this basement. If you say here stars basements, the less number of stairs because of difference in levels. We have to go to existing level, which is 2.6 feet below top. So there's a 2.6 feet difference in stair, not in building. So you can go here, and this, you know, this is structural framing, and you can say this is again front balcony. I'm sorry, not balcony. This balcony is here. This is basement ventilator. You can see front windows. This is double door, 2 panel door, and these are windows. So you can see how much light we shall get in room. That's a question mark here. And this is towards north. This is north entry. And here this is stair. Then we can say same type of internal photos. You see, this is balcony in front. If you see outside, this is double door, this is windows, and this balcony. You see, this is only block work here. All this is internal view. And you may say that this is, you can say, another view, you know. This is outside, this is in driveway, in fact. If you see, this is in driveway. You know, this difference of level is covered here. This is steps, you can't see from this end. Then this is your, go back and see again what I have shown to you, because this is something very little photograph, not all photos I am showing you. the very very little here I showed to you, because this covers many foundations and all views it covers. So I tried to show you what is important here. Stair is very important for you to understand, and it's difficult to draw. It takes time. It takes time as well as you have to calculate, and you can see this structural arrangement isn't easy. It also takes time. Means it takes not only time, it is based on concentration. You have to do analysis as well. It's not simply drawing. You have to do analysis of structures in this case, in every case. Actually, I am real happy that I have shared this file with you, which is, I can't say it's an achievement, but something shared, that's all I can say. I'll just blow up again so that you can see a little better. It's better to see because maybe you cannot see this thing first time. So we can see this, we are moving like that. You can see that we are moving like this. After showing this, I'll close this file because my purpose was to share with you this information. You can see this. This is the teeth of this stair, sloping roof. Cap, you can call it cap, stair cap, building cap. This is the beauty of stair. It's a little bubble of this, so you can see clearly how does it work. Yes, just view on this. Internal lighting. I think I think that things also given in this file. I'll close this file now because the purpose of this file is gone. I'll come back to routine talk. Routine talk already no problem. Talk routine. Let's say now tabletop column works. Yesterday I repeat that. First I repeat foundation just so that foundation. We talked of foundation, we talked of columns, we talked of I was talking of tabletop structure. So RCC heavy compressor foundation box in which we talked about crack gas, propane, ethane also means this can apply to crack gas, propane gas, ethane compressors or whatever else. It's not necessary only compressors. There can be other kinds of foundations, generator foundations, vibratory, all vibratory, not say ensure formation level is achieved. This is a requirement. Ensure formation level is achieved, and you can say by required fill or otherwise. Whereas required fill means, as I said, improvement. I showed to you improvement, soil improvement. So ensure formation level is achieved. Ensure that formation level is duly tested and approved. So when you achieve, you have to test certainly to establish bearing capacity or properties of soil. How? And then precaution required for such area, for ingress and egress, and other safety measures adopted. Then you can say ensure building is well laid and concrete protection applied accordingly. Ensure protection of concrete mechanism. I think protection is repeated here by mistakes. I apologize for that. Ensure protection of concrete mechanism, if so required, is applied. Ensure shop fabricated rebars, of course, uncoated, are received for installation. Ensure that these cut and bent rebars are rightly tagged. Check about on-site fabrication of forms is smoothly going on for vertical sites. Ensure whether or not vacuum test is conducted for concrete protection membrane. Whether or not vacuum test is conducted, which is very, very important point. Vacuum test is conducted for membrane. Then should it be proprietary form? If you have, it should be complied with manufacturer's drawing. Who you should comply with, because you are supervising, you are fabricating that. You mean your team, your foreman, whosoever. Or if you are involved yourself, doesn't mean, because you are in all, everyone, you are all in all. So should be proprietary form. It should be complied with manufacturer's drawings. Check that marking is made on prepared foundations for relocation of rebars. Ensure that delivered rebars are placed properly using required strong chairs of considerable size rebars. Say 25 mm, because foundation steel is very high, very heavy. Even up to 32 mm you may use in these columns. Means these are heavy foundations and heavy steel. Sometimes maybe 200 kg per cubic meter. This can be more than that. Ensure the heavy columns of walls, if so designed, are well placed intact into foundation portion. That is heavy columns. Mind that these bars are always heavy as well. Sometimes bending of rebars is not permitted. It requires special positioning of these bars. What I am to say is, you cannot change position of superstructure bars So positions of bars within foundations can be adjusted accordingly, keeping intact or overlapping, or if you have using mechanical couplers, that's different case. Means it depends on how your designer wants it. Mechanical couplers you want to use, then you have to make, or you have to go to laboratory, or you send this sample to laboratory for testing, ensuring tensile strength is not disturbed, not going. Then ensure that heavy columns of walls, so design well placed, intact into foundation portion. Mind these bars always heavy as well. Sometimes bending of these bars isn't permitted. It requires special positioning of these bars. Since heavy quantity of rebars are required for such foundations, heavy depot chairs are required at various locations depending on expected workload. Ensure the workers to work safely within the space available, because safety is very important aspect. Is first requirement in construction, not second requirement. First safety, then work. No safety, no work. And if you know safety, no pain. If you do not know safety, you have to feel pain. Check fabricated forms are in compliance with dimensions of foundation. Ensure that forms are erected in sequence and well supported. Ensure sequential panel edges are well secured. Panel edges means because you are putting panel and length is 2, maybe 25 meters, and your panel may be 1.2 meters. So if it is 10 panels, this means 12 meters. If it is 15 panels, this means 18 meters. If it is 20 panels, means it depends on 24 meters. So these panels must be well connected in a way that these don't move out. So these are just joined together. So ensure corner panels are well secured. Corner, because there is no tie bolt in this foundation. This is heavy foundations. We have to keep everything stronger by whatever mechanism we have. And ensure access to side of form being safe, and ensure alignment and plumb. Alignment and plumb for forms. Ensure inclined supports are fixed to necessary requirement, which is according to depth it is required, and we have to calculate all points. Then you can say ensure access to inside of form being safe. Ensure alignment and plumb for forms. Ensure inclined supports are fixed to necessary requirement. Ensure concrete spaces are installed to meet rebars requirement. Ensure certain bars on top are allowed to be fixed later, so that entry is allowed to descend to lower bars. What says, and ensure inclined supports are fixed and concrete spaces are installed at meet rebars requirements. Ensure certain bars on top are allowed to be fixed later, certain bars, so that you can get easy entry. If you keep the bars can't enter. So at the end when you do concreting, you can just fix these few bars, keep them ready in all respects and do it. Ensure that sacrificial anodes are arranged. Sacrificial anodes are arranged and their interface connections are so we can say sacrificial anodes are arranged and their interface Connections to foundation rebars are tied up using galvanized wires or cables clamped and ensure that sacrificial anodes to be inserted done is duly validated. It's been inserted in this to be duly validated. Uh, uh, Inspection of this anodes has to be done by going to lower reinforcement mesh. Ensure electrical continuity tests conducted properly on all rebars. Plan for pouring method that has to be approved. Plan for concrete ordering sequence. Plan for pouring work hours. Plan for curing arrangements. And plan for workers deployment. Plan for stepping management of pouring. Plan for thermal controls and plan for working access on top area. Plan for standby army over 2 decades of then plan for working access onto top area. Plan for standby construction joint formwork for stop arrangement to meet any dam. Regards. Now I'll take another time now because I shared with you this sketches. I like to show you again because sketches for mass block concrete frequency case. This is for facility sketches. This general records management document facility on this. I don't know what I mean to say is let me see which sketch is coming in. I always want to show a sketch. That's the important one. Yeah, it's that sketch. I think I'm right. I'll show you again so that you clearly understand what I'm talking of. You can say rotative. Oh my god, it's reverse. So this is that sketch I was talking of, I'm talking of this sketch. This is for compressor, general sketch. This is sketch in general but very important one. General very important one because you see this is tabletop plan grid. You can see yourself it is tabletop plan. I mean this is tabletop plan, not top plan. This is foundation plan. Heavy foundation plan. This is what do you need is this says, and this is your plan at tabletop. You can say this is a real tabletop plan. They are turbo. This is turbo rotation axis. Here is axis, turbo rotation axis, and this is your here. This line is this is column inserts, and for this line is not column insert. This line is axis of this foundation, and this is axis of this foundation. This one, this is concrete dead load. This is leave that off. This is column section here. Turbo axis means you can see yourself this axis and this axis. This is foundation plan. This is symmetrical, but this turbo axis, rotation axis is out or eccentric, you can say. And this is here where this cross, you see this cross diagonal lines. This is void. There's no concrete here. All of the places are concrete. this void plan compress area, and if you see here, this is foundation block, columns and tabletop. Foundation block, this is, you can see, this is here, you may say this is, has gap and there is space between concrete top and machine to come in here. This is epoxy coating, and this is your compressor base frame. On this base frame you will put compressor in and then connect it. So this is tabletop, approximately 2 meters, and here is column 8 meters. This is 8 meters, column 2 meters is this. So this is what I wanted to share with you. So when I talk of foundation, I talk of this portion 2 meters deep. When I talk of columns, thick columns, this is these columns 8 meters. When I talk of this tabletop, is this much. This way we are seeing go. So I talked of this foundations so far, talked of this compressor foundation work, and then I'm saying I'm going to tabletop columns, columns which I just showed to you, this 8 meters column or whatever height you can consider, whatever. Ensure curing for foundation concrete is accomplished naturally, without this cannot do it. Ensure construction joint is established properly. Ensure setting out locations are correct. Ensure column reinforcement is placed correctly to joints. Ensure sacrificial node are fixed to required height. Well anchored. Ensure tanked GI steel plate, stable steel plate insert are available to be fabricated from workshop. Check proper holes are available for fixing by fasteners to form using bolts. Then ensure all form sides are fixed with inserts properly and inspected. So tabletop columns we are talking now, which is a very important item. So we have talked it. Now we have to see. I repeat back also, it is important item. Ensure curing for foundation concrete is accomplished. Construction joint is stable. Setting out is done. Column reinforcement is placed. Sequential nodes are fixed. Anchor and GI sheet plates. Insert steel plates are available. In check holes are available. Ensure sides are fixed with inserts properly inspected. Make sure that all sides are formed or corrected after repair inspection. I hope have close out of forms and carry out. Then make sure all sides of forms are erected after reverse inspection. A closer of forms. Then we go to another critical item, RCC tabletop work, which is a very important part here. Tabletop. Very critical item it is. Very critical item. As I explained before also, I did not do that work on wrong information. Why to do something you know is not acceptable? So we can say in this case can say very well versus tabletop framing, which we may say you have understood very well till now. Now make sure axis of rotation of machine is shown. Ensure grids in both directions are indicated on drawings, and ensure that shop drawings produced and approved. Check whether or not tabletop is to be produced by one casting, and certainly beams of top are quite deep, and construction joint also shall cause practical problems. Therefore, have a discussion with responsible authority in this regard, so that you can go without construction joint in monolithic casting. According to engineering requirement, one go for pouring is appreciable. Check column construction joints are well scabbled. Check formwork is completely erected. Check and ensure check formwork is completely erected. Then ensure fitness of formwork preferable by formwork manufacturer expert. Then check all access scaffolding is installed for ease of working. Check setting out profiles on form of slab. Check all the beams are correctly marked. Check all block outs are going to mix. I'm trying to refresh because it's a very important point in statement. Check that column construction joints are well scabbled. Check columns are rightly marked with datum lines. Check formwork is completely erected. Ensure fitness of formwork, preferably by formwork manufacturer expert. Then check all access scaffold is installed for ease of working. Check sitting time, setting out profiles on forms of slabs. Check all the beams are concerned with violence. Check setting out, check all access scaffolding is installed for ease of working. Check setting out profiles on forms of slab. Check all the beams are correctly marked. Check all blocks are rightly inspected. Ensure that delivered rebars are placed properly. Keep close watch on work since rebars on such works are complicated in design. Yes. Then you can say, make sure, keep close, ensure that delivered parts are placed properly. Keep close watch on works since rebars on such works are complicated in design, and make sure rebar arrangement of placing is rightly followed, and you just you see, make sure cathodic protection arrangement are ready. Installation. And we can say that here deep beams are correctly marked and cathodic protection arrangements are rightly installed. Preparatory works are all in all respects. Check all works. Make sure that level of top of concrete are seen. Significant note that level should be within tolerable limits, as space between top of concrete and machine support bottom shall be required to be epoxy grouted. All temporary and preparatory works require detailed checking horizontally as well as vertically. All locations of defined inserts to be checked accurately, and you can say plan about method of pouring is as boring requires a good thought out repair sequence. Have inspections for all items involved. This is where we have to do this section. This is Void's plan, and this is what we have to do. Then you can say this is what you have to do means how you move on this you have to decide. Means it is not so small also, it's big foundation with in-depth of beams. And you can see this column plan and see and ends. And then you can then you can say everything is ready on this. Very complicated it looks in reality because of congestion of reinforcement, heavy reinforcement, deep beams and different types of concrete beams. It has to go to every hooks and corners of beautiful lamp. We have to see these positions, all this, this cantilever portion, this beams here, somewhere, all this we have to fill. In layers, of course, we cannot fill directly. You cannot say I fill beams first. No, you have to fill in layers, and this should be uniform layer. It should be done in a proper way. That's a very important point. Now we come to swimming pool RC1. Swimming pool, that's, you can say, size maybe it's ordinary 25 by 13 meters. This is Olympic size or internal size. So say meant for local competition. Shallow depth maybe 1 meter and depth 25 meters. This will be 1 meter at barrier 2 and depth. So this is size 25 by 30 meters. Back band is 2 meters and shallow depth is 1 meter. Construction joint, open surfaces, full lights, internal tiling on shelf surface, wool carpet, changing rooms, all which are all common. Structural items are defined herein. And now to realize something is, you know, done in a different way, and we have to seek information about this. There's base slab, which is in swimming pool. Base slab is there. Base slab checking setting out of protocol pool quarters and their alignments. One is checking setting out of pool coordinates and their alignments, and we have to check working area meant for excavation, as well as no clash situation with other required buildings such as water supply and service area. Check safety proposals to be installed during excavation. Check coordinated services drawings duly approved or approve it. Check internal tiling locations, setting out in isometric view properly. So you can very well say that base slab is very complicated because of various issues in this, and we have to follow sequences given by construction joints. So we can say internal tiling locations we have to see is very important in this case. Internal tiling locations, setting on its isometric view probably, check location of open drains around pool for overflowing water, check process plant, room drawings and locations, then check all coordination for all such minor structures for services and meeting purpose. Check all details duly coordinated with balance tank, monolithic with other drawings. Make sure a slope low transfers. And you can say check that excavation being progressed in line with. Make sure slope erosion between shallow and deep end is done rightly. Make sure that all forms and rebar fabricated are available or are being fabricated according to given details. Check that alignment all as well as levels. Check formation is east and prepared to requirement. Make sure blinding works are done to requirement. Make sure concrete protection is carried out to specifications. Then make sure that water bars are available for construction joint for both vertical and horizontal locations. Make sure that these joints are correctly welded by you also make sure these joints are correctly welded by required tool to suit site dimensions. Then check if underground services exist, if you have to put in services, if required under compelling situation, otherwise not preferred as such. Check all raft rebars to be true to design requirement. Check all side forms are erected slightly. Make sure slope portion between shallow and deep end is done rightly. Check welded piece of PVC or say polythene PVC CG construction joint ring is available and fixed correctly, being kept half in raft and half in injection. Hmm. So you can see yourself. This is important point here is. Hmm. You can see yourself. It's very important point here. You read this as important one. I just put it down. Better read it so that I can get much idea of this. In 5 minutes time, be back. So you must have read all points. This is about checklist, and this is about walls and balance tanks. Both all are different. This is about base, which you have gone through, and this is about walls, which I will do it now. And then walls, and then we go for balance tank. So it is talking about walls. Proceed for curing of base slab. Proceed for curing of base slab as well as for walls forms. Base slab and wall forms. Then this is curing for base slab. We have to do. Walls are carried out in alternate base. Walls are carried out in alternate base of construction joint. This is CJ is defined. When CJ is defined, you have to follow CJ. This construction joint is defined on drawing, it's marked on drawing. You have to follow this because it is RCC, water retaining structure, and one side is full stress outside, while inside is not full stress, that we have to take into consideration in water retaining structures. This is differential stresses we assume in designs on water end, where water side that end is different, lower in stress, while external is higher. So wall reinforcement being done correctly, we have to make sure that reinforcement which you provide in walls is done correctly. All services first fix are inserted for walls. First fix services means electrical services or some other services that provide water supply. That's called first fix. Should be done correctly. Check for all services. First fix are inserted for walls. Check vertical construction joint bars are inserted correctly. Means vertical joints, as we did in slab, brown slab, we inserted construction joint PVC bars. We have to continue them in vertical joints as well, because in base we did continuous loop of construction joint, continuous loop with it. Now we have to make connections with vertical by T inserts in that, as we already put in base. We put T joints, must be somewhere we put that, I think. Check welded pieces of PVC CJ ring is available. This is PVC CJ ring is available and fixed correctly, being wrapped in half in draft and half in wall portion. So there's already an you may read it again. I will explain to you at the end also. So CG bars, is construction joint PVC bars, are inserted correctly. Then check all walls are closed by forms after inspection. Check that bolts and supports would not slacken during pour. Bolts and supports would not slacken during pour. This is for wall. Check working platform are ready and erected. Means whatever platform we have done for working of walls, this must be available according to compliance with safety. Then we have to pour it and complete these walls, and then curing processes. We'll see later on how to do this. Balance tank. What is balance tank? Means Deficiency of water exists in swimming pools. Milk uptake, we may call it balancing, we may call it water goes out through, when you jump into that, water goes out through drains, open drains, or drains. This water is lost and we have to use balance tank for the purpose. Make sure base slab, walls and roof of balance tank are carried out according to drawings, according to, make sure that base slab, walls and roof of balance tanks are carried out according to drawings with all inserts plates in. All repetitive operations checks are required as defined on other checklists. Now, firing or shooting range works, and that is also very important point. I'll show you these drawings. We have all drawings. Currently, I don't know where these are, but I'll find sketches of these if I can. I tried, I immediately cannot show you. Let me see if I can find something from that, because sketches, hold on please. I'm not wasting time, just trying to find. Where's this? It's, you can say facilities on shore or method statement probably. I should say method statement, and it is problem is that if I say, let me hold on please. Chapters is method statements, environmental management, equipment, excavation, crossing, building on plant, excavation, crossing, building plant, excavation, is building, water, power generator, water transmission, building house, canopy, test management, road site changes, site obligated, not as this was not, I think this is not that. Let me see if it's index in this. Index for says site environment management, equipment structure. Crossings, and then it is, I'm trying to find where it is. Buildings, concrete RCC walls of control building, mortar for black or seawater basin and visual building, seawater basin and visual building. Yes, flooring system. Blasting, roofing. Water tightness, test steel piping, backfilling, it's not that, termination, road crossings, production, soap waste, cement based epoxy capstones, water transmission, sketch titles, sketch one tank, excavation safety, tank base grouting, compressor foundation, tabletop, seawater surge basin, waterproofing, plaster block, building new seawater lines. Let me see where I can find this. I think somewhere around you can see facilities text. I don't know, sometimes it's difficult to find plans. Project management, project design, production, manual, conditions of contract, sketches, columns, facility sketches, columns, manual sketches, mass block. this like this. Well, I'm not able to manually sketch facility sketch inclusion house design synopsis views and changes cities building. Sorry, I'm not able to find this moment. Pages numbers. We'll see it later on. Don't waste time. I don't waste time this moment. I'll show you all separately. I think it's not worth to waste time now. Anyway, sorry gentlemen, I could not write this now. So I'm showing you a list of firing is shooting range. This is what's item number 27. That is in this case only. What is shooting range? Point remains. What is shooting range? We have to, shooting range. It's not very unknown to you. Must be knowing. Means you have to learn something. Shooters, sharpshooters and other shooters, international shooters. But this is for army, It's not for ordinary work. I'm talking of this range. That is for army, for professional army soldiers. Jaws dimension is 300 meters long, 25 meters wide building. It's not building actually, you can say building. The width is okay. This open to sky is 300 meters length. Open to sky, and there's a 25 meters gap between two walls, and these 300 meter long walls are called baffle walls because your bullet should not go out of these walls. These RCC walls, this is full height RCC walls, and this is going to have many gantries in between. So if you see components of that, you have to understand what components. Main building where you have to sit and operate. This is RCC framed structure. Other is indoor pistol range because there is outdoor range and indoor range. Outdoor is rifle range, indoor is pistol range. So main building is RCC framed structure in which both are there. Inside is indoor pistol range, that's RCC framed structure, and outside shooting range, RCC framed structure as well, both, but outside open to sky. Now bullet truck chamber, that's called BTC, that's also RCC framed structure. All these details I will show you next time, maybe other time. I have sketches of that. I show you before also, I think. Target pits every 100 meter means you have target 100 meter, then 100 meter, then 100 meter. So 300 meter total RCC framed structure. Now underground passes pits every 100 meter below target pit. This is framed structure as well. It's underground passes. Baffle walls. It's RCC ordinary thick walls, 6 meter high, 4 to 6 possibly 6 meter high. Thick wall, not thin wall. Gantries supported on PTFE bearing mounted on corbels. Structural steel armored plate with waterproof board covering, and now you can say polytetrafluoroethylene, this is PT, polytetrafluoroethylene is called PTFE bearing, or heavy, very heavy density, you may say ethylene or plastic, you may say polytetrafluoroethylene bearing mounted on corbels, projection in RCC for supporting armored plate with waterproof board covering. So what is these are? Then sand trap. So these are components. One is main building, in which is in just pistol range and shooting range both. You have to operate from main building. And then there's a bullet trap chamber, bullet trap chamber. Then target pits, underground passages, bullet baffle walls, whole long, 300 meters, baffle wall long. This heights is given here. Remember, it's 300 meters and there is pit, there's a target, sand trap. So this is very long wall. Of course, many joints do exist in between panels. And underground passages, 3 numbers. Baffle walls, 2 numbers. Gantries, 3 numbers. Plate. Then sand trap. Now it's sand trap, not sand trap lower. So refer to attached sketches of firing range. We'll show you sketches, of course, attached somewhere. We'll see. I'm here just giving the sense. Spatial structures are bullet trap chamber, that is RCC framed structure. Target pits every 100 meter, RCC framed structure, and underground passages, pits every 100 meter, RCC framed structure. Baffle walls, RCC ordinary thick walls, 6 to 4 meter high. Gantries supported on PTFE, bearing mounted on corbels. These are polytetraethylene, polytetrafluoride, structural steel armored plate with waterproof board covering. Now checklist for foundation. Concrete pour, cause foundation is there as well. Now we are doing concrete pour. This starts concrete pour for all items. And this is checklist for foundation, footings, concrete pour. Till now we have just worked on preparatory works. Preparatory works means form work and steel placing and fixing based on temporary works. So all are there in position everywhere, and we are now going to discuss about concrete pour. What to do in concrete pour. That's very important point, because that's ultimate destination is concrete pour. So we are going to talk with concrete pour activity, and this is for item number 6, that was preparatory works, and number 28, that is this item, concrete pour. I've just separated that. If I include everything in one, it will be unclear. You can read item 6 and then you can go to this item and understand. I'm not going to 6 item because it will just waste time and confuse. So what to do? We have to plan adequate number of foundations, not one foundation, adequate number of foundations, because of requirement of quantity. We have to place order for, and it's in sequence. We cannot order for one foundation only. Maybe 10, 15, 20, depending on your formwork, because we have to use formwork also in sequence. When we use plywood, marine plywood or waterproof plywood, call it 20 mm or 18 mm, we generally repeat 4 to 6 times depending on what type of foundations you have. So one plywood should be used at least 4 times, if not 6. 4 times means how many similar foundations you have, similar dimensional foundations, and you have to see if you use 4 times how much shutters, how many square meter of shutters you have to buy, and then not only shutters, you have to buy battens also, and how many can you place one time depends. For example, you have 40 foundations, you use 4 times, for 4 repetitions, this was 10 sets you need that. Accordingly, you can calculate and decide. So adequate number of foundations in one go must be planned, and to meet RMC delivery requirements, because one transit mixer 6 meters cube or 8 meters cube or 9 meters cube and how many. Foundation is not slow pour, it's fast pour, particularly square foundations or independent footings, generally 40 centimeter thickness, 30 centimeter thickness, not less, and even more. So quantity has to be placed in such a way that adequate number of foundations are covered, and it's fast pour. If you have a mobile pump, it's very fast pour. You need to be careful that it's not slow pour. Like thickness is more, quantity is more, and it's groundwork generally below, near ground, 1 meter below up. But it looks ground because when you excavate whole area, rather than doing foundation by foundation, sense says that you excavate whole areas, whole where foundations are there, and then do work. So it's better in that case. So book concrete in advance to facilitate RMC supplier, ready mix concrete supplier to chart out RMC plan, schedule. So you have to book concrete. That's your first activity. Book concrete pump of required boom length. You have to tell or that supplier can come itself and see what actually you need. If you are not sure about boom size of pump, or where do you stand that, where position that pump, where's the maximum limit the pump can go, its machine belongs to concrete ready mix plant, so that manager must know, and you can explain to him which pump should be there, one pump or two pump. Maybe sometimes pumps are available and this work is maybe 100 cubic meters, maybe 50 cubic meter. So in 2-3 hours you can comply with, you can finish this, and you must have crew to manage or to digest that. So have site appraised by RMC representative for assessment of timings. Footings, pouring is fast activity which point has to be considered. Prepare pouring platforms wherever required. Pouring platforms means working areas. You have to, so that your shutters are not disturbed, your jacks are not disturbed, your supports are not disturbed. You must have adequate accessible platforms or working platforms. Pouring platforms you can place vibrators, you can allow people to stand. Ensure pouring inspection is over. Of course, inspection must be there. It's over, and inspection testing plan is signed off. Concrete temperature should not exceed 32 degrees Celsius and should not be below 5 degrees Celsius. Generally, whenever you do concrete, it's around 10 to 15 to 30 degrees, 32 degrees. Don't do it more than that. That's not in the interest of concrete itself. In hot weather plan, for concrete pouring, either in early morning hours or late evening hours, at night hours. Make sure that supporting arrangements should not disturb during pour. Make sure vibrators and standby vibrators are available. Vibrator and standby vibrators both are available, because you cannot trust any equipment. It can break any time. It can break whatever time, so you should not stop work. Without vibration, concrete can continue. So keep standby vibrator, which you can use during that standby operation. When it fails, make sure masons tools are available. Make sure adequate number of carpenters and steel fixers are in attendance for meeting certain low profile emergency. Now you have to make sure all arrangements regarding curing are available. Curing, it's the most important activity post pouring concrete. Without this, you cannot survive. You cannot survive in job, and concrete cannot survive in structure. Concrete testing equipments are available either directly or by laboratory. Laboratory which you have, they also do have these site testing activities, and we generally, if possible, we use them, or we just submit reports. Then you see, you can say, uh, make sure all arrangements regarding curing are available, testing equipments are available, concrete testing equipment which are brought yours by you or by laboratory, doesn't matter, you can ask a laboratory to bring those. Make sure that this equipment include slump cone, cube molds, thermometers, air voids measuring equipment or instrument. Make sure that qualified technician is available to test and record all observations. Make sure RMC delivery timings are correctly recorded. Delivery timings means what time these trucks arrive to site, so that we can see what time these start from plant. This gap should be within limits. Make sure that no RMC truck starts pouring delivery at site without clearance from testing position. It's clear. Now make sure that train group or gang to receive pumped concrete is available at location of concrete. Prior to commence with pouring, have vibrator checked for operation. That's a very important point, because you can't trust the equipment, you can't trust tools, you can't trust your machines. Intelligent engineer is that who cares about this. Make sure that location is cleaned well prior to pouring. Prior to commence with pouring, have vibrator checked for operations. Make sure that location is cleaned well prior to pouring. Commences with that location you are going to pour. Check the concrete location is watered well to avoid flash setting. This is a very important point. Flash setting, check that concrete location is watered well to avoid flash setting, because of temperature impact on steel as well as on timber. Could be timber you cannot see that much, but on the steel, even if you are using steel plates, that's a steel, don't forget that. Though we generally don't use steel plates, I don't like it, because I want to use plain ply that gives better surface, and your steel plates will give rougher surface, or no steel plate is well, every plate is sagged and you can't make it original. In case you use steel plates, then heat can impact on that place. So only solution is water. Just spray water before doing, so that it cools down. Temperature difference between surface and concrete is little. You are getting concrete, say whatever temperature in 532, so that temperature we brought down. So 10 means minimum, then say temperature difference exists between surface of steel or surface of timber and concrete. Minimum temperature difference is better than maximum temperature to avoid flash setting of concrete, because flash setting is fire setting. We don't want fire setting which can break wet molecular structure of concrete ingredients. RMC truck after testing clearance and start pouring from pump station. What to say, receive RMC truck, you have to receive it after testing is done, testing clearance, and start pouring from pump station. Pump station is located in your site itself, your transmission. Your pumps are stationed. Footings can be poured in one go, indeed, because if depth doesn't exceed 400 to fear for free, you can take full layer, or you can say one layer if depth is not exceeding, that doesn't exceed 400 mm. Footings can be continuous in case beams are cast monolithic. In case it's not necessary, I have not seen generally monolithic casting because of ends of shutters problem. So generally people leave dowels for these beams, and they You can say footings can be continuous in case beams are cast monolithic. Make sure that no starter bars are displaced during pouring. Starter bars, you know what is starter bars. In foundation itself, we embed steel bars for columns and provide some rings so that these remain stable. And this L portion of these bars remains on in foundation on steel. And we can see that they're held. These bars are held. And with this embedment of depth of foundation length of these bars, including L, remains there in concrete and other portions are left out. So then make sure that no starter bars are displaced during pouring. You must have good binding and good. You can't even connection there. Then you can say concrete occupies all space around bars and forms. Well, that's a must. Means when you're doing concreting, no starter bars, your starter bars are displaced and concrete occupies all space around the bars, reinforcing bars and forms. Immediately after top of concrete is leveled, you have to do with wood. Top of concrete is leveled, no steel finish. After top of concrete is leveled, say about half an hour is over. Curing compound could be sprayed depending on site situation and weather temperature. Don't wait for too long because you have to avoid cracks from concrete. These can form immediately because of shrinkage. So just immediately after you level it, by experience what time you can spray on this curing compound. If you must have, just a spray it, leave it, or otherwise you have to lay polythene around immediately. Something you have to do if polythene is not going to work, then it's working inside even like a common practice is to say immediately after off concrete level, half an hour is within. Or curing compound could be sprayed depending on site situation and weather conditions. No gap should be allowed during pouring for a better pour quality. No gap should be allowed. Pouring is immediate. No, don't wait. Order in such a way that you complete this pour in one footing. It's a common practice not to order last truck, since exact quantity of mix is unknown because of steel quantity, which we don't calculate in calculations. We don't include calculations, but it is that in portion where steel excess or the volume of steel does exist, that volume of concrete is not included. Also, some waste in beginning of pump is not included, and also some at the end is not included. So based on this, difference of course arises, and that difference must be taken care of. So make sure that construction now, if a whole last truck to replace, it's common practice not to order last truck since exact quantity of mix is unknown. Therefore, hold last truck to replace its order after major pour is over. Make sure a construction joint is correctly formed by roughening or scabbling. That's very much point. Testing technician must collect cube samples and record all testing observations. Apply Hessian or gunny rolls or polythene sheets over unformed surfaces and cure with water all times for 7 days at least, and on Then you can say, if you go further on this, I can say testing technician must collect cube samples and record all testing observations, which is very important part. Then we have to apply Hessian or gunny rolls, which is saturated one, and polythene sheets over unformed surfaces and cure with water all times for 7 to 10 days depending on weather conditions. Make sure that curing arrangement is not thrown away by very fast winds blowing around. Then prepare at least you can say. Then hardened concrete, make sure curing arrangement is not thrown away by fast winds. Hardened concrete should not be allowed to dry whatever time till curing is over. Don't let this dry. Water must be there. Curing mud must be there. Intact with the surface, and hardened concrete should not be allowed to dry whatever time till curing is over. Side forms can be removed after 24 to 36 hours, which is normal practice. This was, checklist for stub columns, concrete pour. Stub columns, Raja. Good morning, Mr. Rajan Santosh Mandosam. Good morning, Mr. Rajan Santosh Mendonsa. Good morning. Good morning. Thank you very much for joining, Mr. Raja. I'm here to share my information with you. Great. So, checklist for stub columns, concrete pour. This item, Simon, in this list, and this is 29, I'm going to share. This is checklist for stub columns, as I explained to you. Stub columns, column within foundation, column within soil, and that is part of foundation. You may say it's not part of foundation, in fact it's part of, but let us consider, because it's a part within soil up to plinth level, this is called stub column. Or you can say, just like we call starter parts, you may say starter column, but it's a stub column in real language, real terms. So you have to plan adequate number of such stub columns for pour in one go to meet RMC delivery requirements, because there is a problem in stub column. It's very small quantity in one column. For example, you take 30 by 30 column, or 30 by, even say 50 by 50 column. It says only 1 meter depth of stub column, so it's only 0.25 cubic meter. 25. I'm talking of not 50 by 50 columns, 30 by 30, 40 by 40, but let's say even 50 by 50 columns is 0.25 square meter into 1, so 0.25 cubic meter, and 0.25 cubic meters. If you take 10 columns, then you can say only 2.5 cubic meter. So quantity of concrete in stub columns is very small. You have to take that care. Means how many columns can you prepare one go, or do you arrange? Can you have arrangements of your own mix if it is permissible? And if it's not permissible, then you have to take from them, from RMC, only through transit mixer, and arrange to pour yourself using either crane or otherwise, because pump will not be available for small quantity of concrete. So you must have done hard work, or you can say smart work, for on your location. So you have to plant adequate number of columns. You pour them in one go and book concrete accordingly to facilitate RMC vendor to chart out plans of supply or schedule. Factually, it's inconvenient for RMC supply to small quantity. That's why I said. So book concrete pump of required length in case pump is available. If not available, you have to alternately Arrange also stub pour is required by pump, but stubs may also be done using pumpless pour because quantity is very less, so it's better to think on that. As is convenient to you, if get pump easily fine, pump is fine, but remember quantity when pump drops into column is a small quantity, small is you know it's not convenient based on experience. So yeah, it's now there's no straight direction on this. Check stops not more than 2 meter high in general because drop is never allowed more than 2 meters. Generally it's less than 2 meters generally. If you take 1.5 meter foundation, then even if it's 2 meter foundation, you can say remove 40 centimeter or 50 centimeter foundation pad, so it's 1.5 left. So check the site provided means are feasible for pouring RCC. RMC site provided means are feasible, or you have to make ground that prepare available for entering trucks and all that. Check if site pour means are utilized. RMC should not be delayed excessively during pouring. Don't delay because there is some problem with delay. In case it does not contain microsilica, you cannot delay it. In case it contains microsilica or silica fumes, there's different timings, but in case it contains only PFA or GGBS or only OPC or SRC, you have to think on that. You have no right to delay that RMC quantity. Checks all stubs planned for pouring are safely accessible for pour gang. Means whatever planned pour stubs, they should be accessible. All elements should be accessible without problem, without fail. Or you can say now can say check that all sub planned for pouring are safely accessible for pour gang and make sure mason's tools are available. Adequate number of carpenters and steel fixers must be available, and they make sure adequate number of carpenters and steel fixers. Carpenters means formwork carpenters, not other carpenters, are in attendance for meeting certain low profile emergency. Low profile emergency means say some support is out, you can say something can happen, so we have to keep in position again. In case steel fixer is required for some bar is broken or some binding wire is broken, let's take it out. So So make sure adequate number of carpenters and steel fixers are attendance for meeting certain low profile emergency in case of concrete pumping used. Make sure that only required quantity of mixes are poured into stub to prevent concrete from dropping around stub preparatory works. Don't waste concrete difference that, just quickly take off. Because concrete pump is very fast and quantity of concrete in this stub is very small, so you have to be careful because if concrete falls or drops outside, you can't use that, you can't pick it up. Ensure vibrator is applied rightly. Ensure vibrator is applied adequately and rightly into stub portion without touching reinforcing bars or forms. You can say, in case what happens, I repeat, in case of concrete pumping use, make sure that only required quantity of mix is poured into stub to prevent concrete from dropping around stub preparatory works, right? And ensure vibrator is applied rightly into stub portion without touching reinforcing bars or forms. In case vibrator touches forms, chances of form opening are not acceptable. There would be chances of form bulges out or opens. We can't accept that. Vibrator must not touch forms. Vibrator must not touch your steel also, reinforcement also. It should go directly without touching neither formwork nor steel reinforcement. Check all curing materials required for stubs are available on site, including curing compound. Now with concrete, I say with concrete truck arrives, while concrete truck arrives, collect sample for slump air voids test. All trucks must be checked of slump and air voids. Check loading and delivery times. Loading at plant, at patching plant, time and delivery times. And also check RMC dockets. From dockets only you can check this. Time is written, what time start mixing, what time is stuck left from there. So you know what time it has come now. This so informative data is available. So we have to check loading and delivery times according. Check from our data sheet. Check then yes. Then allow truck to move on into location, station for delivery. Once you give clearance to truck, okay, your slump is fine, your air void is fine, you have seen temperature as well, so you can move on to go to site, go to pump and deliver your concrete. So allow truck to move into location where your pump is stationed or where you have to use some other means, crane, mobile crane or tower crane, or otherwise how you do your headache. Check site prepared open, check site prepared open chutes. Sometimes we use site prepared open chutes for purpose of pouring such smaller quantity of concrete. So check site prepared open chutes are available in case of pump less concrete, so that concrete can be easily transported to stub. But in this case you have to make sure if you are not using pump, you are using either tower crane or you are using mobile crane, or otherwise slump limits are changed. In pumps limit is more, it's 100 mm for example, and in non-pump case where crane and direct pour is there, it is 75 mm, it's not 100 mm. So you have to ask your plant operator what slump you need, because ultimately it is related to equipment you use for pouring concrete. In certain cases, wheelbarrows, steel wheelbarrows can also be used for transporting concrete from truck. Small buckets can also be used for collection of concrete and pouring into stubs. Again, I read this very important one, because if you use such lower profile equipment, then you have to think that way in case of steel. In certain cases, steel wheelbarrows can be used for transporting concrete from truck. Small buckets can also be used for collection of concrete and pouring into stubs. Mobile or tower crane can also be used for pouring stubs if available. Make sure that stub is concreted in layers, not exceeding 400 to 500 is generally 2 or 3 layers density. Not more than that. You have to upgrade. Don't allow full depth because it's structure. It's not. You can say on structures. So make sure that transfer. Make sure vibrator is efficiently used after laying pouring. After layer pouring, make sure that vibrator is efficiently used after layer is poured. You can say that way. And don't excessively vibrate, which people do by mistake. They don't understand what's pouring. Was using vibrator. They go on pouring and vibrating, thinking that you're getting more dense. No, that's not true. It will efficiently vibrate only the point where it start. No? Now make sure that no supports are slackened during pouring, and also make sure that after pouring stubs to their marked top level, top is covered with polythene or Haitian as convenient. Don't leave it otherwise. People generally leave it. Immediately you cover with polythene. Don't wait. Then after you label it, though you cannot finish it, you can label it and you cover it with polythene sheet or Haitian as convenient. This is temporary measurement, right? Make sure that no supports are slackened. It's very important point. Supports are slackened or slackened. Even if you want to use a butt joint, I think that is So, what we say, that's right. Now, make sure that no supports are slackened during pouring. Make sure that after pouring stuffs to their neck mark top level, top is covered with polythene or Hessian as convenient. I think there's some voice problem. Make sure after pouring stuffs to their marked top level, top is covered with polythene or Hessian as convenient. Make sure that no supports are slackened while using pumpless pour are remote chances of forms opening, but with pump chances are more. Make sure that foremen or charge and type supervisors do not allow water to be added to concrete during pouring. It often happens that during long pour and concrete truck getting getting delayed, concrete stuff is stiffened, causing hardship to workers. And to avoid this hardship, they tend to add water to mix, which is not acceptable in any case in any structural concrete. So it is very important issue. Even sometimes foremen do this nonsense, and engineer rarely stand outside. So this is, a kind of unacceptable. And if by chance suppose someone looks at this supervisor or consultant or someone and says, okay, take sample of this, it becomes a problem for. So you can say, make sure that foremen or charging type supervisors do not allow water to be added to concrete during pouring. It often happens that during long pour and concrete truck getting delayed, concrete stuff is stiffened, causing hardships to workers. To avoid that, they tend to add water to mix, which is not acceptable in whatever case. Start curing after few hours depending on temperature, but sides of forms externally can be kept cold by spring water. Side forms can be removed after 24 hours to 36 hours in case of foundations, but takes time while opening forms due to many reasons, not one or two. So don't worry about that. It always takes more time for forms to be removed. So what we did today, if you just see, we today we did cover lot of activities of construction. Good morning, Mr. Amar Shah. Good morning, and please don't call me, don't disturb me. This is important talk. This is talk for serious people, and this is construction talk. I don't know why people want to call without questions. You can write questions here. I'm not sitting here to just see your face or my face to show. Well, I can say we covered today length of, you can say we talked of strip columns, concrete we talked of, foundations, concrete, pour, and then we can say talked about firing, shooting range, preparatory works list, RCC swimming pool works, which is basis slab walls and balancing, and also tabletop works as well as RCC tabletop column works, thick members and heavy composite foundations refreshing. Then also I shared with you a long file which is about a house structure. If you want to see it again, I can just open it in a minute to show you. And that is house design synopsis, and it's an important one. You can see that. I'll not blow it up, just see what we did. We refreshed that structural elements of that. We walked on, we spent time on that, and maybe it is useful for everyone. A structural arrangements of foundations and architectural attraction. We did that in this, and you can say just in a shoot file, just for refresh, did this. So you just the architectural course that browsing again for all those might not have chance. It's actually it's about 500 square meter plot, 120% coverage, complete RCC structure, same technology, same framing design, three-dimensional design, and no isolated footing in that. That's what this is. That's the beauty of this. So I just close this file. Just wanted to refresh you what we did in this, and then of course this file which is moving we'll take care of later on. Now tabletop works has gone, the RCC footings there, walls and everything. Then we'll take, we'll turn up to here, concrete pour step columns. We'll take grid slab later on because now it's some time to closing time. If I take more time, may not be good. Purpose is to, what was purpose of this is an important one. You can say our purpose is to improve quality. That's my sole purpose, not to push on, because I have seen not only in here, all over this country, and also in some parts of other countries. We should not say in this country alone, but because I belong to this country, and I must have more concern. Quality of concrete has fallen drastically, you can say beyond imagination. People do not understand concrete here. Even I have seen engineers too, no different. Everybody is using, you go and see every site you will find generally rusted bars are being used, which is complete nonsense. I don't know what they are doing, believe me. And just photograph on Facebook. I feel irritated when I see such rusted bars placed in structures. I don't know what those engineers are, whether they qualify for. I raise question to myself. I write to many. What made you use these rusted bars? Nobody answers. Either answer. Clarify why you are using this. But only show, photo session, means it is a clearly non-engineering activity. How can you permit, even if you say contractors use, what for you are there if contractors use that? After all, you are responsible, not contractor, for supervision. So even you see steel stored somewhere in open and all bars are rusted. Nobody takes care. Means what sort of engineering does it happening in this country? What sort of engineering is this? It is engineering or just certificate you have? Engineering means if you are certified engineer, you should use it. You should prove that you are engineer. Means don't care for anything. Just it's my project done. I know that it will go in concrete, it will be concealed from view. But is that your approach to accept something going concrete? Nobody can see that. Are you watchmen? Nobody can see that. You are responsible for durability of concrete. Means you think you'll get concrete durable in case rusted steel is inserted in? No. This will create problems. Means why after all? Why? For what? What benefit you're getting? Question arises. And people are not even worried about leveling of slab. People are not worried about verticality, plumb check. They are worried about dimensions. Yes, you can cover everything by thick layer of plaster render. That what we do. Are we born for that? My point of view is that. Are we born engineer to cover defects? Are we defects covering engineers in India, Bharat? Are civil engineers meant, or objective of civil engineers is to allow bad quality work? Question is that. If you say yes, we are there, we are guards for those crooked people to go home. We are guards for hiding their defects. Then I think I can't answer that. But job of engineer is to do correct work. I do not see your bad or good design. I don't see that. You claim I'm structural engineer, I'm this, I'm tech, I'm PhD, and you are allowing rusted steel, you can say non-workmanship on site in terms of my duty is only to give design, deliver design, and I'm not responsible for anything else. If you think that's right, well, I can't answer that. That observation, your comment, nobody can answer that. If your mental setup is that. Why did you do engineering? If you can accept all this, you are just a contractor, layman, drain contractor who doesn't care for everything. People don't even understand transfer of movements on site, how to put bars for transfer of movements. They don't understand means movements from beams to columns. No one understands means whatever given scheme means. I'm following. Okay, if you follow him, follow. You are a follower. You are not engineer who can lead. Nobody cares. Covers are not available, and they don't care. And sometimes they don't cast covers. I know in foundations plastic covers won't work. They just put in. I don't know. Vibrators not applied properly. They pull concrete. They just play with concrete. After all, nobody cares if there's no ply. They put planks, timber planks, and there's joints not butt properly. They don't plane these surfaces because it's all rented. And there's a gap between two planks through which slurry goes down. Means something is there. You can't say this is quality control. There's no quality at all. I can say 98% cases, in 98% cases, even in metro I have seen what quality they give. Only, trademark. I go and see closely, you will find so many observations about quality. I should not say that, but that's a fact. We should not hide facts. We are not facts hiding civil engineers. We are facts producing civil engineers. We produce structures that will work for centuries. It's not 2 years or 3 years car, 5 years car, 2-3 years television set, or 5 years life of fridge. It's not electronic equipment, it's not mechanical equipment, it's not vegetable, or it's not some other item that we have to buy again next year. It's not shudder to reuse, or we can throw it. It's lifelong good, that is lifelong good structure for your coming generations. So quality, it is your duty as an engineer. That's why I say civil engineer is some primary engineer in world who cares for these materials, who must care for. It's your duty. Maybe you don't have very good suit to wear, you don't have very good dressing sense, you don't have very good English language, you don't have very good polite language, no problem for that. If you can give you quality, if you can deliver quality, everything is off. This is very important point. We should take care of this, and if we take care of this, I think with the best interest, we we consider God as civil engineer too. God is civil engineer because God constructed this universe. We should learn from that. Means he did not even a defect in the universe. He so and see perfect working of system. Of course, there's methodologies and their system defined, but it doesn't deviate. So why we? Why do we? That's a very important point we have to think of. And if we can think of this, I think I will start a society. I would like to say then, that now times they are to close this talk for today, keeping we continuously, and I will thank all those who joined, like Engineer Rajan Santosh, Mendoza, and Mr. Amar Shah, and all those who would later read this, view this. I'll be thankful if you can pass your comments in this. If you like it, don't like it, it's up to you, but I think I am just submitting my ideas, my observations to public. Of course, engineers include public, and it's duty of engineers to pass technology to public, not to keep with them. It's not happening. It's not happening. Something else is happening. You are more worried about quantity, you are more worried about valuation, you're more worried about billing, you are more worried about your turnover. But what is turnover of quality? Nobody is worried. Nowhere I can say. It may be private sector, it may be government sector. Mindset has changed. Mindset has changed. Purpose of engineering is left. Well, I should not all time criticize, but this only purpose of my long talks. I want to raise questions to people. I want to give feedback to public based on my small experience. I'm not very experienced engineer. I'm not having any highest degree. I'm just an ordinary person. But I have seen works of those who claim highest in doctorate. They are not interested in site works. They are not interested. They are only interested in design works or in research. So there you can say I can't comment on that. It's up to them. But don't forget that if you design perfect, if site is not perfect, your design has got no meaning. That is also a very important point. We should take into consideration all this. If you are a good one, you have everything that's called good one. So be clear about that. Life is not what you think. It's all different. And I would say now in a couple of seconds, because I like to continue this more, but there are limitations for everything. You 2 hours Monday today, and you have to go to job. It's already 7:37, and I'm going to close this talk in a couple of minutes. It's already 4 hours over. I started at about 3:30 something. It's over, no problem. Facility by Facebook, you can pull. So my dear friends, I would say now to you all, thank you very much for your kind attention, and I understand that you will review all this video and past videos, this long list of videos. Maybe you don't have time to go through all this, so whenever you have time, or you present your own statements, your own videos. I've seen many videos on YouTube by many engineers. And of course, it's good means you participate in that. It's good one we should do. Also, it is important we have to participate with that. So with this, I will like that I should take leave now. It's enough for today. And I wish you all good time.